Hi my dear friends, welcome back to our YouTube channel. This is ADC Maths. Welcome back. I am fine. How are you? I hope everyone is happy and safe in your homes. Please take care of your health. So in this class, I am going to start the applications of the one-dimensional wave equation. Okay. What is one-dimensional wave equation? As we know that the one-dimensional wave equation is dou square y by dou t square is equal to a square into dou square y by dou x square. So this is the one-dimensional wave equation. If I solve this, we get the displacement function, and this is called the tension of the string by mass of the string per unit length. This is a fixed constant. If I solve the given one-dimensional wave equation, we get the displacement function y of x comma t. So that is my requirement. Let us see that. Let us read the question. Your string is stretched and fastened to 2 points x equal to 0 and x equal to L. So what's the mean that? What's the meaning of this one? So the string is fixed at the two endpoints, right? This is the point x equal to 0, x is equal to L. Right? So this is the length of the string. It is fixed. So this fixed means obviously there is no displacement taken place at the point x equal to 0 and at the point x equal to L. Isn't it? It's clear? Now, motion is started by displacing the string into the form of y equal to lambda into Lx minus x squared. So initially the string is allowed to vibrate with some displacement y. So displacement is given here. That means that velocity is considered as 0, assuming that the velocity is 0 because of initial displacement is given, isn't it? Now the question is from which it is released at the time t. So time t equal to 0 means that is initially. So initial displacement y is given. So what about the displacement function in general at any point x from one end of the string and at any time t? So when I allow the string to vibrate, so this is the y-axis, this represents the time factor t. During the subsequent motion, when I fix at any point, at any time, what will be the displacement function of the given string? So that is the question now. So from this problem, what we have from this problem, what we get this is the 0 initial type velocity. So it is 0 initial velocity type. So once the velocity is 0, what are the boundary conditions? We have the following boundary conditions. What are the boundary conditions? Let us tell me that. What are the boundary conditions? For this type, the velocity is 0. The initial velocity is 0. What will be the boundary condition? So the first boundary condition is for x equal to 0. For the first boundary condition, x is equal to 0. At this point x is equal to 0, there is no displacement because it is fixed. So for all the time t greater than or equal to 0, for all the time t greater than or equal to 0, right? What about second boundary condition? For the second end. So first boundary condition for the first end x equal to 0. Second boundary condition for the second end at x is equal to L. So once again it is fixed, so no displacement for all the time t equal to 0. That's right. And third one, it is initial velocity is 0. So initial velocity is 0. Initial velocity is 0. So what's the mean that v is equal to dou y by dou t at the time t equal to 0 is equal to 0. In between 0 less than x less than L. In between 0 less than x less than L. In between the 0 less than x less than L. It's clear? Now, what is the fourth one? The fourth one is the initial displacement function. It is already available in the given question. So, the initial displacement function is y of x comma 0 is equal to f of x is equal to lambda into Lx minus x square in the interval 0 to L. Why it is in the interval 0 to L? What is the reason? Because at x equal to 0 it is fixed. So, no displacement at this point, and x equal to L also it is fixed. So, there is no displacement at that point. So, that's why we have considered the first two boundary conditions for x equal to 0 and x is equal to L. So, that's what we have considered. So, two boundary conditions for x, two boundary conditions for time t equal to 0. So, two for x, one for x equal to 0, one for x equal to L. Okay. Then third and fourth condition for time factor, time t equal to 0. The velocity is 0 means the third one comes velocity 0. Displacement is now non-zero, it is given in the question paper. So we have to collect the data from the given question. Is right, sir? Now, I am going to apply these conditions one by one, this condition one by one into the correct solution. What will be the correct solution? What is the correct solution? Yeah. Also we know that the correct solution, also we know that the correct solution for the equation number 1 is given by y of x comma t is equal to a cos px plus b sin px into c cos pat d sin pat. There is a separate video I made for all possible and the correct solution by using the method of separation at variable techniques. Please go and watch. Right? So this is my required correct solution. In this correct solution, there are some unknowns a, b, c, d and small p. Let us find out the orbital constants with the help of these boundary conditions one by one. Now the first case, now using the condition number 1 in this equation number 2 by putting x equal to 0, we get. So substitute x equal to 0. So where we have x here, so cos 0 becomes 1, sin 0 becomes 0, 0 into b is 0, so a into 1 is a. There are no x in this term, so it is c cos pat plus d sin pat. But at x is equal to L, the point was fixed, so there is no displacement at x equal to L. Isn't it? So it is equal to 0. It means that the product of either a equal to 0 or c cos pat plus d sin pat is equal to 0. Isn't it? Right? But what I think that c cos pat plus d sin pat cannot be 0. Why? There are many reasons are there. The first reason, suppose this value is 0, what happened? The entire thing becomes 0. We get a trivial solution. But initially we have some displacement lambda into Lx minus. Okay? So this is the contradiction case. The other one is the first boundary condition when x equal to 0, the displacement is 0 for all the time t. So whatever so, the minimum value for t is 0, isn't it? Even though when we substitute the minimum value for t equal to 0, I am getting cos 0 is 1, sin 0 is 0. So 0 into t becomes 0, c into 1 becomes c. So we get only c equal to 0. But when we get this value 0 completely means both c and d become 0. But both c and d become 0, we get y is 0, which is the contradiction. So definitely this value is not equal to 0 since either c0 or d0. Right? So it is not equal to 0 for all the time t greater than equal to 0. So this is not equal to 0 means which one is 0 then? Which one is 0? Yeah, the only balance is a. So hence a equal to 0. Now substitute a equal to 0 in this equation number 2. Substitute a equal to 0 in equation number 2. Substitute a equal to 0 in equation number 2. What I am getting that? Let us see that. Substitute a is equal to 0 in equation number 2. So substitute a equal to 0 in equation number 2, we obtain the revised, the updated displacement function y of x comma t is equal to, now a equal to 0 ma. So b sin px c cos pat plus d sin pat. Is right? Is right? So this is the equation number 3. Now this is the latest one. It's clear? Now, so the first conditions we applied, we get a equal to 0. Now second one, at x equal to 0, the displacement is 0. Now using the second boundary condition, in the latest displacement function equation number 3, by putting x equal to L, we get. So replace x equal to L, because first two boundary condition for x alone. So b into sin p, what's the x now? L. And this is c cos pat plus d sin pat. So what about x equal to L? At the point x equal to L is fixed, so there is no displacement. So this is equal to 0. So product of these three equal to 0 means either b equal to 0 or sin pl is equal to 0 or c cos pat plus d sin pat is equal to 0. Isn't it right? So product of these three values equal to 0, 1 we get 0. So any one must be 0. So what I think so the last one is already we have explained here, so it is not equal to 0. Since c cos pat plus d sin pat is not equal to 0 because of the minimum value for t is 0 even though it is, so this is not equal to 0, is right? So this is not equal to 0 for all t greater than 0. What about b equal to 0? Yeah, the same case. If b equal to 0, already we found that a equal to 0. Now already a 0, now b is 0, what happened? The at a time becomes 0, 0 and anything becomes 0. Got it? Right? So either a0 or b0. Similarly here, either c0 or d0. Both the constants become 0 in the same term, then the entire term becomes 0. So this is not correct. This is absurd. It is a contradiction to the given data. Isn't it? So already we found that a equal to 0. So if b equal to 0, already a0, we get a trivial solution. Isn't it? So this is the contradiction, so that b is not equal to 0. So therefore b is not equal to 0. So b not equal to 0. C cos pat plus d sin pat not equal to 0. So therefore which one is 0 then? Sin pl equal to 0. So when we get sin term 0, it's a multiples of pi. So sin n pi equal to 0, sin pl equal to 0. So by equating the like coefficients on both sides, we get pl equal to n pi. N is a positive integer, pi is a fixed constant, L is the length of the string. So which one is unknown? P is the unknown. So P is equal to n pi by L. So here I got the P value and I substitute P is equal to n pi by L in the latest equation number 3. In the latest equation number 3, we get y of x comma t is equal to y of x comma t is equal to y of x comma t is equal to b, right, sin n pi x by L. Let us see that. I substitute the p value n pi by L, p value n pi by L, p value n pi by L. So c cos n pi at by L plus d sin n pi at by L. So this is the latest displacement function, equation number 4. Equation number 4. This is the latest one, equation number 4. Is right? Is right, sir? Now, so I applied the first condition. I found that a equal to 0. I applied the second one. I found that p equal to n pi by L. Now, I need to apply the third boundary condition. What's the third boundary condition? Velocity. What's the velocity? Rate of change of displacement with respect to time t. But here what do we have? We have only the displacement. So let us differentiate this equation number 4 with respect to t, then apply the third boundary condition. So now I am going to differentiate the equation number 3 now. So differentiate the equation number 4 partially with respect to t. Partially with respect to t on both sides we get. On both sides we get. What we get? The left hand side is dou y by dou t. The right hand side with respect to t, sir. So this is only the t term. So what about the b sin pi x by l? It is fixed. So there is no need to bother about this b sin n pi x by l. Let us differentiate the c. C is a constant. Yes, a product form c. Cos differentiation is minus. So this comes minus sin n pi a t by l. The constant term is n pi a by l, isn't it? By using the chain rule, so we multiply n pi a by l plus d is a constant, yes, right? Sin differentiation cos. So cos n pi a t by l into the constant n pi a by l by using the chain rule. By using the chain rule. Right, sir? With respect to t, so c cos becomes minus sin n pi a t by l into n pi a by l plus d sin becomes cos n pi a t by l into n pi a by l. Got it? Right. Now, what is the third boundary condition? Initial velocity 0. What's velocity? Dou y by dou t. Now, can we use the condition number 3 now? So, I can make this is equation number 5. I can name this equation number 5. So, using the condition number 3 in number 5 by putting t equal to 0, we get. By putting t equal to 0, we get the left hand side is dou y by dou t at the time t equal to 0. What's mean by dou y by t? Velocity. Time t equal to 0 is the initial velocity is equal to 0. Initial velocity is 0 time, isn't it? Now what about this side? B sin n pi x by l, because there is no t term, so I can write as it is there. Now when I substitute t equal to 0, sin 0 0, so this is completely 0. This is completely 0 when t equal to 0. When t equal to 0 here, cos 0 becomes 1. So it is d into the constant term n pi a by l. So product of either b or sin n pi x by l or d or n pi a by l equal to 0. So product of any one becomes 0. So b is equal to 0 is not possible. So b not equal to 0, because of already a equal to 0, we get a trivial solution. What about n pi a by l? It is a positive integer, pi is a fixed constant. A, what's a? Square root of tension by mass of the string per unit length, isn't it? What about L? L is the length of the string, so obviously all are non-equal to 0. What about sin n pi x by L? Sin n pi x by L is also not equal to 0, since 0 less than x less than L. Why this is not equal to 0? Tell me. This is equal to 0 only when x equal to 0. For example, let's see that when take x equal to 0, what I am doing that? Sin 0 0. But x equal to 0 is the very first condition. I have already used that one. You see that? I have used when x equal to 0. So that is already true. What about x equal to L? When x equal to L, we get sin n pi. That's also 0. Yeah, right? Because that's the second condition. Yeah, when x equal to L. They have already discussed separately x equal to 0 and x equal to L. So we don't bother about at x equal to L and x equal to 0. What about in between 0 to L? We can choose anything like L by 2. We choose x equal to L by 2 and we can get sin n pi by 2. This is equal to 0. Sorry, this is not equal to 0 because of if n equal to 0, sin 0 0. If n equal to 1, sin pi by 2 is plus 1. N equal to 2, sin pi becomes minus 0. N equal to 3, sin 3 pi by 2 minus 1. N equal to 4, sin 2 pi 0. N equal to 5, sin 5 pi by 2 is plus 1. So this is not at all 0 for all values of n. So that's why this is not equal to 0 in general. So which one is not 0 now? This is not equal to 0, this is not equal to 0, this is not equal to 0. So the final one is d equal to 0. Now substitute d equal to 0 in this equation number 4. So using or substitute d equal to 0 in the equation number 4. We get equation number 4, sir, because y of x comma t. Y of x comma t only, not in this equation number 5, because 5 is the velocity, but I need the displacement. So displacement is fourth one. So let us substitute the value of b equal to 0. We get it is b sine n pi x by L. Now d0, so c cos n pi at by L. So there are two trigonometric terms, periodic terms, one for x, one for t. One for x, one for t. And still there are some unknown boundary conditions above. Unknown constants. What are the constants? C and B. C and B. These two are the unknown arbitrary constants still we have. So what I am going to do that? I am going to combine this B into C as some Bn. So let us, for n equal to 1, 2, 3, etc. What we will get? We get an infinite number of possible solutions. Let us see that. Why I don't put n equal to 0? If you put n equal to 0, sine 0 becomes 0. We know already. So by putting n equal to 0, it is waste of time. So I start from n equal to 1. If I put n equal to 1, n equal to 2, by giving the different values for b and c, b equal to 1, c equal to 1, I get one possible solution. B equal to 1, C equal to 2, I get second possible solution. B equal to 1, C equal to 3, we get third one. Similarly, B equal to 2, C equal to 1, B equal to 2, C equal to 2, B equal to 2, C equal to 3. So continue like that, we get an infinite number of possible solutions. Among all possible solutions, let us collect all feasible solutions. Then we get the optimum solution, is often called as most general solution. So for n equal to 1, 2, 3 up to infinity, we obtain the most general solution. We obtain the most general solution. Most general solution. Y of x comma t is equal to, by summing up all possible solutions, we get capital Bn sin n pi x by L into cos n pi at by L. So this is the required displacement function. But in this most general solution, still we have one arbitrary constant, capital Bn. So how to find the constant value capital Bn? How to find the constant value capital Bn? Yeah, still we have one more boundary condition in my hand, y of x comma 0, initial displacement. So by using that condition, we may easily determine this constant value. So this is my superstar equation, star equation. So in this star equation, I am going to apply the fourth boundary condition. Let us see that. So using the fourth boundary condition. In the most general solution. Using the fourth boundary condition in the most general solution. Let us see that. Finally, using the condition number 4, it's the last boundary condition, no other options are there. So using the condition number 4, in the most general solution equation star, by putting t equal to 0, we get. What we get? We get y of x comma 0 is equal to sigma n is equal to 1 to infinity capital Bn sin n pi x by L. What about putting x equal to 0, that is t equal to 0, cos 0. What is cos 0 value? 1, which is equal to the given displacement function lambda into Lx minus x square. This is the only condition, non-zero condition. Non-zero boundary condition always kept in the last case. Understand? Okay. Now, still we need to find out the Bn in the most general solution. So, my ultimate aim is to find out the Bn value with the help of the given data, lambda into Lx minus x square. So, if I see this stage, the left hand side I have sine and x. This looks like half-range sine series. So, can we express this left hand side as a half-range sine series? Can we do the same for the right hand side? What will get? So, can we expand? What will get? To find capital Bn, to expand the f of x as half-range sine series, in the interval 0 to L. What do we get? We get the left hand side is sigma n equal to 1 to infinity capital Bn sin n pi x by L is equal to, now right hand side is sigma n equal to 1 to infinity small bn into sin n pi x by L. Isn't it? By comparing both these sides, what we will get? Equating like coefficients on both these sides, we get capital Bn is equal to small bn. What is the formula for capital Bn or small bn? 2 by L interval 0 to L f of x sin n pi x by L into dx. Is right? Is right? So can we substitute the Bn here? So small bn and capital Bn both are same. So 2 by L interval 0 to L lambda into Lx minus x square into sin n pi x by L into dx. Let us apply the Bernoulli formula here. What we will get is equal to 2 by L, lambda taken outside, 2 lambda by L using the Bernoulli formula. So Lx minus x square, sin integration is minus cos n pi x by L by n pi by L, close the bracket, minus the formula minus Lx minus x square, integration is, differentiation is L minus 2x, right? And cos integration is plus sign, so minus sin n pi x by L by n pi by L to the whole square, close the bracket, plus the formula L minus 2x differentiation with respect to x is minus 2, sin integration is minus, so minus or minus becomes plus cos n pi x by L by n pi by L whole power 3 with the limit 0 to L by using Bernoulli formula. If I substitute x equal to L into L squared minus L squared 0, substitute x is equal to 0, we get 0 minus 0 squared 0. So this term is completely 0. Similarly, the middle term, when x equal to L, sin n pi 0, by putting x equal to 0, sin 0, 0. So this is also 0. So only we have this much one. Only we have this much, that is minus 2 cos n pi x by L by n pi by L whole power 3. So what about my capital Bn? It's equal to 2 lambda by L, is right? Now let's take the minus 2 outside, minus 2 L cube by n cube by cube is a constant term. After cancellation of 1 L, this becomes L square. What's the balance now? Cos n pi x by L. So cos n pi x by L, if I substitute x equal to L, I am getting cos n pi. If I substitute 0, I am getting cos 0. So from this, I found that Bn value is equal to, small bn is equal to minus 2 L squared lambda. So minus 4 lambda L squared by n cube pi cube into cos n pi value is minus 1 whole power n, cos 0 value is plus 1. Is that right? Is that right? Now, if n is odd, if n is odd, if n is even, if n is odd, this term comes minus 1. This is also minus 1. So minus 1, minus 1, minus 2. Minus 2 into minus 4 is plus 8. So 8 lambda L squared by n cube by cube. Once again, I repeat this. If n is odd, minus 1, minus 1, minus 2, minus 2 into minus 4 plus 8. If n is even, this becomes plus 1, 1 minus 1, 0, so it is 0. So capital Bn values exist only for the odd values. So once we know the capital Bn value, let's use this in the most general solution. We get the required displacement function. Is right? We get the required. So let us substitute capital Bn value in the most general solution, star equation. We get what we get. So use this in the MGS. Y of x comma t is equal to summation. The Bn is exists only for the odd values. So 1 comma 3 comma 5 to infinity. 8 lambda L squared by n cube pi cube. That's it. Into sin n pi x by L So one x term, one t term, cos n pi at by l. Because y is a function of x and t. So this is x term, this is a t term, is the required displacement function. Is the required displacement function. So this is the solution for given one-dimensional wave equation, the string problem with initial velocity 0 and given some initial displacement. Understand? I hope you may understand this. Thank you for watching our YouTube channel. Please subscribe, support, like and share our YouTube channel ADC Max. Thank you so much.